Back with another update for useSoroban.app. This time it's to do with raw values. I've finally added support for all raw value encoding and decoding, and I'm going to show you exactly how that looks in the interface right now. Starting with the small value type. This is a type that can be encoded fully within 64 bits, and it's all accessible without going to the host environment. So you can see this is a contract that has two sections: test small value output and test small value input and output. Pretty self-explanatory. In the action section, everything's compiled. You can just start clicking. So this returns a false. This returns true. This is a void value. Specifically, since there's nothing returned in Rust, there's a value type that's inferred, and it's the sort of Rust version of none. Okay, then we have various kinds of status messages. If you uncomment these values, you can change them, and you'll be able to see different results. So we shifted over into this error message. Let's go back to the way it was. Okay, so we have status messages, then we have unsigned integers. This is the biggest unsigned int that we can fit inside of 64 bits. This is the smallest value for a signed integer of 32 bits. We can also fit almost an entire not almost, but a large part of an unsigned integer, 56 bits. And same goes for the unsigned version. So just half the size of the unsigned. Now the values for U128 are pretty much the same for as they are with 64-bit integers, but the difference is Rust still thinks it's an I or U128, but it's stored in the 64-bit raw value. Then we have symbol values up to 9 characters. And then finally, we're on to inputs. So the prefix above was RO, return output, and here it's RI, return input. So we select false, we get a false return. Now this button splits into two. We can click it again to call this function again with the same inputs, or we can click on the dots and change the value. So we have false and true for the Boolean inputs. Now the only way I can output a void was using an option. So if you don't provide anything, a value for an option, then it returns null. But if we select some value in 33, then it returns that value. We can also input just an unsigned integer or a signed version. Same goes for U64 and I64, and the rest are the same. All right, so this covers the small value section. We can go back into the Explorer and select the host value. Now, values over here are hosted in the host environment, and what you get as a raw value is a pointer back and forth. So we can start with the unsigned 64 integer. You can see a much larger value here. And if you uncomment these, you can experiment with some of the key ranges here from lowest to biggest and so forth. A much larger version of unsigned 128 and a signed version. Now a fun type, byte. The encoding here is using the macro, but the output is sort of a legible version of that. Then we have a new type called string. We can encode UTF-8 symbols, and just for fun, I've added an emoji here to demonstrate that. Symbols that are larger than 9 characters are hosted in the host environment. And you can see this is larger than 9. And then we have vector values and a map. Scrolling down, we can see that there's also an address output. You can hard code the public key using a bytes n value. And this points back to an abstraction I created for the address field in the host environment. So this is, think of this as index 2. We can change this to index 1. There's 3 addresses in the host environment. We can call address again, and you'll see the name is Bart. I'll show you exactly the 3 users later. And we have the log output, returns nothing, but you can see a nice log with string interpolation. Okay, now on to the input and output section. So for input, RI, we can use the same values as we did in the previous section for U64, I64, U128, and I128. Now, bytes, this is more interesting. We can provide a list of bytes, 1, 2, 3, 4, 5, and we get 5 bytes. Or we can do an unsigned, a base 64 encoded value. This is a string that can take any kind of UTF symbol. And this is just a symbol that's limited to alphanumeric characters and an underscore. Defining a vector. So we can do 1, 2, 3, 4. Let's see, we remove 2, confirm. We can see 1, 3, 4 in the console. This is a map, symbol map key, and a U32 value. So let's do 1 and 1. Set another 1, 2, and 2. Confirm. See the output matches up. And the address. So this is what I'm talking about. There's 3 addresses in the system. So it abstracts the long address values and provides a nicer experience for the user. So you can just select your user, whether it's Alex, Bart, or Callie, and the system will know what to do and how to interact with these users. So this covers the section of host and small values, and you can see that we've covered all available values as per the SDK. So this is the SDK definitions file. There's a false, a true, a void, a status value, U32, I32, 64 smalls, and time point and duration are not implemented yet. So that support will come later. Then we have U128 and I128. U256 and I256 are not yet implemented. Symbol small, we were able to see. A ledger key contract executable. I didn't have a way to demo this. And that covers the small value section. The host values are as follows. So we have a U64 and I64. We were able to see that. Then time point and duration have not been implemented in the SDK, so that doesn't exist. We've seen U128 and I128 values. U256 and I256 are not implemented, so that's coming later. Not implemented in the SDK, I mean. Then we have bytes, string, and symbol, which we were able to see bytes, string, and symbol. And then we have a vector and a map, which again, this is a vector, this is a map, input and output decoding and encoding. Contract executable object, didn't have a way to demo, and the address is the last input right here. And this I don't believe is implemented yet, so didn't have that. And that covers the entirety of the raw value types. Thank you, and I hope you enjoy the product so far. And if you have any questions, please feel free to ask. Bye now.